So V2 is the voltage of the intersheath 2 with respect to earth. So we know that the stress at a point which is at a distance x is inversely proportional to the distance x and is given by Gx is nothing but equal to Q divided by 2 pi epsilon x, where Q is the charge, epsilon is the permittivity, and then the x is the distance. So we know that epsilon is equal to epsilon naught into epsilon r. So substituting that, the formula will become Q divided by 2 pi epsilon naught epsilon r x. The electric stress G1 between the conductor and the sheet 1 is going to be G1 is equal to K1 divided by X. K is going to be the constant which we are treating, and the K1 is nothing but a constant. We are going to treat it as throughout the formula, throughout the derivation of this derivation, we are going to consider K1 as the constant. Let's find out the potential difference between the first intersheath and the V, that is the core. That is first potential difference between the first intersheath is going to be V is equal to V minus V1. So when we say that the V is the total potential, V minus V1 will be equal to the integral of D1 by D divided by 2 to D1 divided by 2, because we are moving from the core to the first intersheath. So integral from D by 2 to D1 by 2 of G1 into dx. So substitute the formula for G1, which is nothing but Q divided by 2 pi epsilon naught epsilon rx into dx. By integrating, we know that the constant is going to be the K1, and Q divided by 2 pi epsilon naught epsilon r is considered to be the constant. So K1 divided by x into dx. By integrating this, we are going to get the formula as K1 into ln of D1 divided by D. And K1 is nothing but equal to, when we cross multiply this, V minus V1 divided by ln of D1 divided by D. Let's treat it as third equation. So if we substitute the third equation in the second equation, we get the G1, which is nothing but the potential difference, the stress, that is G1 is equal to V minus V1 divided by x into ln D1 divided by D, which is going to be the fourth equation. So to derive the formula for the maximum stress when at a distance D divided by 2, that is from the core to the first layer, that is the outer surface of the conductor, x is equal to D by 2 on the core surface, we can substitute the formula for the x, that is the D by 2 is the distance. So G1 maximum will be equal to V minus V1 divided by D divided by 2 ln of D1 by D. This is the maximum stress on the core surface. So let's treat this equation as 5. Similarly, potential difference between intersheath 1 and intersheath 2. The first intersheath and then the second intersheath we need to find out. So obviously the formula will be V1 minus V2. That is going to be the potential difference, because V1 is the potential difference at the intersheath 1 and V2 is the potential difference at the intersheath 2. So G2 will be equal to V1 minus V2 divided by x into ln D2 divided by D1. Keep this as equation 6. So now we can find out what is the maximum potential difference on between the intersheath 1 and intersheath 2 is G2 maximum will be equal to V1 minus V2 divided by D1 divided by 2 ln of D2 divided by D1. Keep this as equation 7. So now the next task is to find out the potential difference between the intersheath 2 and the outermost sheath, that is going to be the same as V2, because there is no extra potential that is applied. Only 2 layers have been introduced. We have considered only 2 layers for the derivation, the purpose of derivation. So the third layer will be the outermost layer, which is at the same potential as V2. So the potential of the intersheath will be maintained at V2 only with respect to the earth. And we also know that the outermost layer, which is going to be the lead sheath, which is maintained at the ground potential. So the V2 will be the voltage, that is the potential that is appearing on the outermost layer. So we can derive the formula for the maximum potential difference, that is on the outermost layer, as G3 is equal to V2 divided by x into ln D divided by D2, where D is the diameter of the whole cable. That is G3 will be maximum when x is equal to D2 divided by 2. So G3 maximum will be equal to V2 divided by D2 divided by 2 into ln D divided by D2. Keep this as equation 9. So by choosing the proper values of V1, V2, G1 maximum, G2 maximum, etc. can be made equal. So our task is to make the uniform stress distribution. So we need to find out what are the potentials that can be applied to make G1 maximum is equal to G2 maximum is equal to G3 maximum. So since the dielectric is homogeneous here, we are not using the composite dielectric here. We are using So the purpose of introducing the intersheaths is to make the potential difference, to bring in the potential difference, and to make the uniform stress distribution all over the cable, so as to make the cable as efficient one and to optimize the capacity of the underground cable for the voltage that it is designed. So since the dielectric is homogeneous, the maximum stress in each layer is going to be same. That is, G1 maximum is equal to G2 maximum, that is equal to G3 maximum. The stress can be made to vary between the same maximum and the minimum value as shown in the figure. So by showing the D1 and D2, by choosing the better values of the D1 and D2, such that D1 divided by D is equal to D2 divided by D1, that is equal to D divided by D2 is equal to alpha, and G1 maximum is equal to G2 maximum, that is equal to G3 maximum, then we can derive the formulas which we have derived for D1 by D. From the formulas you can say that V minus V1 divided by D divided by 2 ln alpha, because when we see the equations which are nothing but 7, 8, 9, you can see the variation that is between for each one of the layers. You have the combination, that is D1 divided by D, D2 divided by D1, as well as you have got D divided by D2. So only thing is that when we see this formulas, the G3, that is the stress that is going to be inversely proportional to this combination, we can make this G1 maximum is equal to G2 maximum is equal to G3 maximum by choosing the values of this. So we have considered that D1 divided by 2, D, and D2 by D1 and D by D2 is equal to alpha. So we can substitute the formula. So we get V minus V1 divided by D by 2 into ln alpha is equal to D2 by D1, whatever the formula that we have derived from the equation 8, V1 minus V2 divided by D1 by 2 ln alpha. Again from the equation 9 we can write this as V2 divided by D2 ln alpha. So if we take out the common factor here, which is nothing but half ln alpha, and if we cancel this, the formula can be reduced, that is the equation can be reduced to the equation number 10, that is nothing but V2 divided by D2 is equal to V1 minus V2 divided by D1, that is equal to V minus V1 divided by D. Keep this as equation 10. So all that we have done is that we have taken out half of ln alpha from this equation and we have cancelled it, and we have come to we have reduced the equation to V2 by D2 is equal to V1 minus V2 by D1, that is equal to V minus V1 divided by D. So keeping this as equation 10, we can move to the next formula to find out what is going to be the value of V2. V2 is equal to, from this we can reduce the equation further. V2 is nothing but cross multiply this D2 divided by D1 into V1 minus V2. This is equal to alpha into D2 by D1 is nothing but alpha. So reduce it to alpha into V1 minus V2. Expand the equation, that is alpha V1 minus alpha V2. So finally take out the common ones, like 1 plus alpha into V2 is equal to alpha V1. So V2 will be nothing but alpha divided by 1 plus alpha into V1, alpha divided by 1 plus alpha into V1. So this is going to be, let's keep this as 11 the equation. So let's try to express the voltages V1 and V2 in terms of V and alpha, which is nothing but V1 minus V2 divided by D1 is equal to V minus V1 divided by D from the above expressions. So cross multiply this, V1 minus V2 is equal to, simplify the equation, V minus V1 into D1 divided by D. This is equal to D1 by D is again alpha into V minus V1. Therefore V1 minus V2 will be nothing but equal to alpha into V minus alpha into V1, that's again 1 plus alpha into V1 is equal to alpha V plus V2. Keep this as equation 12. If you substitute equation 11 in equation 12, you are going to get the expression for V1, that is 1 plus alpha into V1 is equal to alpha V plus 1 alpha by 1 plus alpha into V1. Substitute and then simplify the equations and bring in the equation as V1 is equal to alpha into 1 plus alpha V divided by alpha square plus alpha plus 1. So if you simplify it further, V1 into 1 plus 1 by alpha, 1 plus 1 by alpha plus 1 plus 1 over alpha square, that is, keep this as equation 13. And similarly you can express V2 also in terms of alpha. Substitute the equations, you will get the expression for V2 also, which is nothing but